Okay, so now we're going to learn about adding and subtracting rational expressions with unlike denominators. So the key here is we want to rewrite it with a common denominator so that then we can add and subtract. Okay, the simplest case is if we had four numbers like a over c plus b over d. And c and d are factored all the way. So we want to get them to have the same denominator, so we would multiply a over c by d over d so that it has a denominator of dc. And we want to multiply b over d by c over c, okay? Because then we would have d times a over d times c plus b times c over d times c. So now we've got the common denominator, and we can add the numerators. So that would become d times a plus b times c over d times c. Okay, I think the simplest way that we can understand this is to start with some examples. Okay, I'll go back to these directions in a minute. So, if we had 3 over 4x minus 1 over 7, okay, our denominators are factored already, so we don't have to worry about factoring them yet. But we need to multiply the 4x by 7 and the 7 by 4x. Now whatever I do to the bottom of a fraction to keep that fraction the same, I'm going to do that to the top of the fraction. Okay, so I'm going to multiply this by 7 over 7, and this fraction I'm going to multiply by 4x over 4x. So what that becomes is if I multiply my numerators here, I have 21 over 28x minus 4x over 28x. So notice I've created a common denominator here. And now that I have a common denominator, I can combine my numerators, so I have 21 minus 4x. And notice those are not like terms, so I can't simplify any further. And then on the denominator, I keep the denominator, and I have 28x. Now if we could factor this on the top, the numerator, then we might be able to simplify further, but since we can't, this is as far as we can go. Let's see, I am going to, generally I like to get in the habit of rewriting these so that they are in standard form, so I'm going to rewrite it so that my x term is first, so that's technically negative 4x plus 21 over 28x, but these are equivalent expressions, so you could write it either way. It's just I generally like to write it this way because it makes factoring easier if you're able to factor it. Okay, so let's look at this second example here. I have 1 over 3x squared plus x over 9x squared minus 12x. So we want to rewrite both of these in factored form. So this is the same as 1 over 3x squared can't be factored any further. Okay? Then I want to factor the denominator here. 9x squared minus 12x. Well, both 9x squared and 12x have a common factor of 3x. So I'm going to bring that out front and then rewrite 3x, because 3x times 3x gives me 9x squared, and then minus 4, because 3x times negative 4 gives me negative 12x. So I've now written everything in factored form. Okay, I'm going to come along with another color, and in this separate color we're going to write off to the side that we're trying to find the least common multiple or least common denominator here. Okay, the least common multiple of the denominators. So we have in our first denominator here 3x squared. So that's 3 times x times x. And then in our second denominator, okay, we have 3 times x times 3x minus 4. Okay, so I want to look for, remember we want to only count each of these once, but we want to count them all once. So the least common denominator here is going to be 3 times x times 3x minus 4. Okay, so I want to look for in each one, what are they missing from the least common denominator? For example, 3x squared has 3x squared, the 3 and the 2 x's, but it's missing the 3x minus 4. So that's what I need to multiply it by. So on the top I'm going to multiply it by 3x minus 4. and the bottom as well. I think I said that backwards. On the top and the bottom. So make sure you're multiplying both parts of the fraction, because that's like multiplying by 1. Okay, now, the green denominator that I've highlighted over here, it's missing the x from the least common denominator. So we're going to multiply the numerator and the denominator by x. Okay, I'm going to follow down here in the next step and multiply both the top and the bottom by the number that I've chosen. So here we have 3x minus 4 in the numerator. And then in the denominator, I don't even have to worry about multiplying these out because I know that it's going to eventually be my least common denominator. So I can simply write 3x squared times 3x minus 4. Okay, then I'm going to write my second fraction here. So on the numerator I have x times x, that's x squared. In the denominator, okay, we have 3x times x, that's 3x squared, times 3x minus 4. So I've created a common denominator. Now when I want to add those, I don't add the denominator, so I keep the denominator the same. And then I add the numbers from the numerator. And I like to write in standard form, so in order from highest exponent to lowest exponent. So I'm going to write x squared plus 3x minus 4. Okay, the final step is to factor this numerator and see if anything can cancel out from my numerator and the denominator. So I'm going to write out x squared plus 3x minus 4 off to the side. I'm looking for factors of negative 4 that add up to 3, so that is x plus 4 times x minus 1. Notice neither of these are factors in my denominator, so writing these in factored form would not simplify any further. So this is my final answer. Okay, let's look at a second example. So again, we're going to factor both of our denominators before we do anything. So this is the same as x. And actually I'm going to write this down here so I've got more room for myself later. So this is x over. I'm looking for factors of negative 12 that add up to negative 1. So it's going to be x minus 4 times x plus 3. Because that gives me, let's see, 4 and 3 add up to negative 1. And then negative 4 times positive 3 give me negative 12. Okay, and then in the second fraction I have 12x minus 48. 12 goes into both of those numbers. I'm going to bring it out front. I'm left over with x minus 4. Okay, so I'm going to use my two different colors again. So in the blue, let's see, I have x minus 4 times x plus 3. That's my blue denominator. And my pink denominator is 12, which I'm going to write out front, times x minus 4. Okay, so let's see, my blue denominator is missing a 12, so I'm going to multiply the top and the bottom by 12. I think I went off the screen there. Here. Well, let's make sure I multiply my numerator and my denominator by 12. And then my pink denominator is missing the x plus 3 right here, so I'm going to multiply that by x plus 3 on the top and x plus 3 on the bottom. Okay, the next step is to multiply across, so I have 12 times x, that's, let me get my black pen again, that's 12x, and then in the denominator I have 12 times x minus 4 times x plus 3. Okay, let's look at the second fraction here. So I have 5 times x plus 3, or 5x plus 15 if you distribute. Okay? And then in the denominator I have 12 times x minus 4 times x plus 3. Okay, so I have a common denominator. The denominator is the same in both fractions, so that means we can go ahead and keep that denominator and add the numerators. So there's my denominator. And then I have 12x plus 5x plus 15. Now go ahead and combine your like terms in the numerator. So that's really 17x plus 15 on the top, and then 12 times x minus 4 times x plus 3 on the bottom. Okay? You don't have to worry about multiplying the 12 or factoring the top, because 17 is a prime number, so we can't pull out any factors there. So this is our final answer. Okay, one final example for adding with uncommon denominators. Again, we're going to start by factoring our denominators. So we have x plus 1 over, this is x plus 2 times x plus 2. Okay, you can do that off to the side if you need to. It is a perfect square trinomial. Notice 2 times 2 gives you 4, and 2 squared gives you 4. And then over here, x squared minus 4, that is a perfect square, or I'm sorry, a difference of 2 squares, so that's going to factor to x minus 2 times x plus 2. Okay, I'm going to use my two different colors here. So in the pink denominator, this is x plus 2 times x plus 2. My orange denominator, let's see, I'm going to have to change my pen here. Okay, the orange, I have x plus 2, just one of them, and then an x minus 2. Okay, so from the, let's see, in the pink, I am missing an x minus 2. See how the orange has an x minus 2 and the pink does not? So I'm going to multiply the pink by x minus 2 over x minus 2. And then I'm going to multiply the orange by another x plus 2, because it needs one more x plus 2. So in the next line, I have x minus 2 times x plus 1 over my least common denominator, which is x minus 2 times x plus 2. And instead of saying x plus 2 twice, let's just write x plus 2 squared. That'll save us some time when we're writing. Okay, then we're going to subtract 6 times x plus 2 over x minus 2 times x plus 2 squared. Okay, so notice our denominators are the same in both fractions, so that means we can go ahead and simplify and go to the next step by subtracting. Okay, now if we have x minus 2 times x plus 1, remember that we're multiplying two binomials, so we're going to have to FOIL them. So you can either write that off to the side or write it in the next step. So we have x times x, that's x squared. X times 1, that's x. X times negative 2, that's minus 2x. And then negative 2 times 1, that's minus 2. From that, we're going to subtract the quantity 6 times x plus 2. So go ahead and think about distributing that. You can do that in this step now if you want. So that's 6x plus 12. And instead of writing a bracket here, I'm going to write a parentheses. Okay, and then we keep our denominator, so that is x minus 2 times x plus 2 squared. Okay, next we want to combine our like terms in the numerator. So we have x squared, positive x, and a minus 2x, that's minus x, if you want to think of it that way. Okay, so we have x squared minus x minus 2 minus 6x minus 12. Don't forget to distribute that minus sign to both numbers. Okay, then we're going to put that over x minus 2 times x plus 2 squared. The final step, we still have to combine some more like terms here. So we have x squared minus 7x minus 14, and then x minus 2 times x plus 2 squared. Final step, we want to look, can we factor this? So can we factor our numerator? We're looking for factors of negative 4 14 that add up to negative 7,